Hi.
Okay, here we go. First one, a type of reproduction. Fission, budding, regeneration. One produced from one organism. It's identical to the parent organism. What kind of reproduction is this, Connor?
Asexual.
Very good. Cell that has half the number of chromosomes as a body cell. What kind of cell is that has half the number of chromosomes? We talked a lot about numbers yesterday.
Yeah.
David?
I think sex cells. Or
Haploid, yep, that's the correct term for it, but you're right, it is a sex cell. A type of reproduction in which two cells, usually an egg and a sperm, join to form a zygote. It will develop into a new organism with unique identity. What type of reproduction is this? Brittany?
Fermentation.
No, that was from a chapter ago. Sarah?
Sexual.
Sexual reproduction. Cell process in which the nucleus divides to form two nuclei, identical to the original nucleus, in a series of steps. All of those. Oh, excellent. Reproductive process that produces 4 haploid sex cells from one diploid and ensures offspring will have the same number of chromosomes as the parent organisms. We learned about this yesterday. What do we call that process? Where we get 4 haploid sex cells in the end. Okay? Meiosis. In asexual reproduction, the joining of sperm and egg. Joining of sperm and egg. Place of fertilization. Haploid sex cells formed in the female reproductive organs. Ryan? Egg. Haploid sex cells formed in the male reproductive organs. Sarah?
Sperm.
Okay. New diploid cell formed when a sperm fertilizes an egg. It will divide by mitosis and develop into a new organism. Sam? What is that new cell called? It's the diploid cell, and it's been a sperm and an egg fertilized. Kind of fun to say. Did you say it? Zygote. Good job. A structure in a cell nucleus that contains hereditary material. Where's your hereditary material stored? It's a structure in the nucleus. Lauren? Chromosome. Good. Cell whose similar chromosomes occur in pairs. Oh. It is a diploid. Good job. Okay, those are all of our words so far. Some of them were new and we haven't even tried that yet. Okay, please open up your book to where we read about meiosis today. One where it has the pictures. 106, 107. Where it has the pictures of the 2 faces. And we took lots of notes in our notebook. Go ahead and pull out your notebook. Let's take a quick glance at what we wrote down, just to refresh our memories. Someone tell me, what did we write down for prophase 1? What did we write down for prophase 1 in our notebooks? So as you see everyone's notebook out, they're looking. Ryan, what's prophase 1 say? Chromosomes are duplicated. Remember, duplicated means like copied. Okay, so first your chromosomes have to be copied. What about metaphase 1? Lauren?
Duplicated chromosomes form up in the center of the cell and spindle fibers attached to it.
Exactly. So this stage is very much like mitosis, isn't it? It's very similar. Okay, what is different though about metaphase 1 in meiosis. What's different between mitosis and meiosis with this stage? Something to do with the spindle fibers. Does anyone remember what we talked about? Hope, what do you think?
The two spindle fibers are attached to the centromeres and metaphase.
Okay, exactly. So in this one, metaphase 1, only one spindle fiber is attaching to the chromatid. So that means that it's not going to separate, is it? You need to have pulling from each side, but there's only one spindle fiber attaching to it. So in anaphase, what happens? Anaphase 1. Normally in mitosis, there would be some splitting and separating going on, but Lacey, what happens in anaphase 1?
Chromatids don't separate pairs of chromatids are pulled together.
Exactly. So they do not separate and they're just pulled back to that side of the cell with their one spindle fiber. Okay? Then for telophase 1, what happens? David?
The cytoplasm divides.
Okay, there they actually split into how many cells? 2. Okay? Those 2 then go on to meiosis 2, the second phase. Okay, so what happens in prophase 2? Ethan, what happens in prophase 2?
Duplicated chromosomes and spindles return to cell.
Okay, they reappear. Metaphase 2, we have lining up in the middle again, but what's different this time? Lauren?
Duplicated chromosomes from just one cell. Each centromere attaches to
You're right. Okay, so this time we have 2 spindle fibers, one from each side of the cell grabbing. Okay, look at that picture of metaphase 2 in our book on 107. You have a spindle fiber grabbing the centromere from each side. So since you're going to have that on each side, it's going to be pulling them apart. Okay? So then they're going to be back into their one strands. All right, then anaphase 2. Austin, what happens?
duplicated. Wait, metaphase?
Anaphase 2.
Centromeres and chromosomes divide, separate, and move to opposite ends of cell.
Then telophase 2. What happens, Brittany?
The fibers disappear and nucleus forms your chromosome.
Okay, then after meiosis is done, then they actually split into their 4 cells, the haploid sex cells. There's 4 of them. Okay? All right, which phase is more like mitosis, do you think? Phase 1 of meiosis or phase 2? Which is more like mitosis? Which one has more similarities to mitosis? Lacey, what do you think? Meiosis 1? Maybe. Except there's one big difference in meiosis 1. Anybody else think? Sarah?
I think it's meiosis
Probably meiosis 2, but why, Sarah?
2. Because the chromosomes are split into.
Yeah, just like in mitosis, in anaphase, there's actually splitting going on into their single strands again. In meiosis 1, it doesn't quite happen. They stay in their pair. So that's one big difference. So mitosis and meiosis 2 are very similar, except that it's happening with 2 cells at once. Okay? All right, very good. Now we're going to go ahead and do our little activity. Go ahead and shut your books. Unless you think you might need your book to arrange your pieces.
I'll use my little.
Just to refresh your memory, you are going to get a paper plate, Tootsie Rolls, and pipe cleaners. The Tootsie Rolls are going to be which piece of the cell? Centrioles. I heard it. Very good. The centrioles. Okay? And then your pipe cleaners are going to be which piece?
Spindle fibers.
Chromosome.
No, it's
chromosomes, the chromatids, okay? All right, so you are going to, hi, we're having class. Okay, you are going to get a pipe cleaner and you're going to cut it into 4 equal sections. And then do that again with your second pipe cleaner. So you'll have 8 pieces all together and twist 2 of them together. So you should have 4 chromatids. Okay? And you're going to get 4 Tootsie Rolls. Once you get all your supplies done and ready, what's going to happen is this is going to be like your mat of where you're going to be working, okay, and arranging. I'm going to call out a phase. So I might say anaphase 2. And you will need to arrange your pieces to look like anaphase 2. Okay? Or I might call out a different one. So there's 8 different phases I could call out. And you will have to arrange them on your cell. This is going to be your cell. Okay? Alright, so can I get some people to help me pass out materials? David, if you ever want to play. Awesome, go ahead and hand everybody 2 pipe cleaners. It doesn't matter what color you're doing. And start cutting your pipe cleaners and twisting them together. Get everybody 4 Tootsie Rolls. Do not eat your centrioles. You will not get a replacement. At the end, you might eat.
I'll see you drop one.
I have scissors at my desk. There's 3 pair there. Scissors I know. You can start cutting. Yep. So you should be cutting each pipe cleaner into 4 pieces. Each pipe cleaner into 4 pieces. Scissors here?
Yeah.
You can share scissors here. Okay. Each pipe cleaner is cut into 4 pieces.
Okay. Evenly?
And twist them together evenly. Yeah, try and do them evenly.
Okay, do it same time.
Anybody? Good. Try and do them evenly if you can. Doesn't have to be perfect, but should we get enough? Nope, you're good. I put some extra in there.
Where do we go?
4 pieces evenly. And all together you'll have 8. Then start twisting them together. I would twist same colors together.
Really?
Yep.
Oh, I got those.
Same colors together. So blacks with blacks, reds with reds,
Yeah.
and so on. We could go through all the colors, couldn't we? Yep. And make them look like a chromatid.
Yay!
Oops, did she cut 5 instead? That's okay. So try and twist them together to make it look like a chromatid. So you should have 4 chromatids when you're all done twisting. Awesome, I don't need a chromatid. Do you have 2 microns?
Yeah.
Oh, you twisted them like that. Then you look like a chromatid, dude. Like an X.
Listen to me.
I was like, where are all your pieces? You're missing them. It's okay, he was busy handing out supplies. He wasn't concentrating on instructions. I wouldn't twist them too many times, I should have told you that. Because you might have to pull them apart in which phase? Anaphase 2. You might have to pull them apart. So I wouldn't twist them too many times. The bad thing about pipe cleaners is after you twist them so many times and undo them and then twist them again, sometimes they snap, yeah, they break. So we'll see what happens with that. Okay, almost ready? All right, let's play our little game. You have 4. Yep. So look in your picture. Usually there's 2 at each end, or that's what they show in the picture anyway. Oh, should you unroll them? No, you can just leave them in the wrapper for now. Because they're going to be touching a lot. You probably don't care if you touch your own, but that's okay. All right, are we ready?
Yeah.
David, are you having trouble? Do you need some assistance? Okay. Are you petting your chromatid? Oh, geez. All right, here we go. Ready or not? You'll have to join in when you're ready. Okay, the first one. Show me prophase 1. You can use your book to help you. For now, anyway.
Thank you.
Yeah, use all of them. So you should be arranging your centrioles and your chromatids. Okay. Try telophase 1. This is difficult. You should almost have 2 plates, huh? That's okay. Make it, yep, I like how you did it there. Then kind of make it obvious that there's some on one side and some on the other.